Okay, today we're going to talk about the chain rule. The chain rule is the derivative of composite functions. Remember, composite functions are functions like f of g of x. That's a composite function. So if you're asked to take the derivative of a composite function f of g of x, the chain rule says that the way to apply it is you have to do the derivative of the f function evaluated at the g function times the derivative of the g function. Okay? If you look at the f function as the outside function and the g function as the inside function, you can say the derivative of the outside evaluated at the inside function times the derivative of the inside function. Okay? Okay, here's another notation called the Leibniz notation. So if y equals f of u and u is equal to g of x, then the chain rule is the same as dy over dx equals dy over du times du over dx, where dy over du is evaluated at u equals g of x. So we're going to use this notation to start us off. I think it's easier to understand if we are barely starting to deal with the chain rule. Okay, so let's look at an example. So here we have y equals 3x squared plus 1 quantity squared. So if we're going to use the Leibniz notation for this problem, we are going to let the inside function be u. So if we have f of g of x, the inside function is u. Okay, remember that in the last slide you wrote that u has to be g of x. So let's do that. The inside function here is 3x squared plus 1. So let's let u equal 3x squared plus 1. Okay? So now what we have is y equals, let's see, so y equals u squared. Okay? So the derivative of u with respect to x, du over dx, is equal to 6x. And then the derivative of y, with respect to u, so dy over du equals 2u. So in other words, what we have here is that the derivative dy over dx of that composite function, remember that Leibniz notation says that dy over dx is dy over du times du over dx. So dy over dx is equal to dy over du is 2u times du over dx is 6x. Okay, all I did was grab those from here. And let's not forget that u originally was 3x squared plus 1. So when I plug in u back in, I get dy over dx is equal to 2 times 3x squared plus 1 times 6x. We can stop here, that's okay. But again, if you want to be gutsy and distribute, that's 6x squared plus 2 times 6x, and then distribute one more time, dy over dx. Now we're going to distribute this way. We get 36x cubed plus 12x. That's the answer. Okay? Let's try this problem. So, think about it. What would you denote u? What would you let u equal here in this problem? Hopefully you see that u is x to the fifth minus 7x. So if u equals x to the fifth minus 7x, then that means that we now have y equals e to the 9. My derivative here with respect to x. So how do I know that I'm taking the derivative of u with respect to x? That's because we have u equals x to the fifth minus 7x. Every variable here is x. So we get 5x to the 4 minus 7. So we have the second equation, y equals u to the 9. Y equals, and then every variable is a u. This is dy over du is 9u to the 8th power. Don't forget, the Leibniz notation says dy over dx is equal to dy over du times du over dx. Okay, and from this point on, all we do is plug in what we found. So dy over du is 9u to the 8th, that's a u, times du over dx is 5x to the 4th minus 7. So this is dy over dx. Again, this is our u, so let's go ahead and plug that in. So we have dy over dx is equal to 9 times x to the 5th minus 7x to the 9. So 9u to the 8 is now 9 times x to the 5th minus 7x to the 8th times 5x to the 4 minus 7. That's your answer. You can stop here. I'm not going to multiply all this. You can stop here. Try this one. Pause the video. Give this one a try. So hopefully you rearrange this to x cubed plus 2x to the 1/2. by rearranging this to x cubed plus 2x to the 1/2, you see that the inside function, should be x cubed plus 2x, making y u to the 1/2. So then du over dx is 3x squared plus 2, and dy over du is equal to 1/2 u to the negative 1/2. So when you do the dy over dx is equal to dy over du times du over dx, we just start plugging in what we found. Dy over du is the 1/2 u to the negative 1/2 times du over dx is 3x squared plus 2. So dy over dx is equal to that. So plug in x cubed plus 2x in for u. So you get 1/2 x cubed plus 2x to the negative 1/2, and the 3x squared plus 2. And that's your answer. Let's try one more. Now, y equals sine of 4x. So, pause the video, think about what you will let u equal. So what's u going to equal? So u should equal 4x here, meaning that y will be sine of u. So we have du over dx equals 4. And the derivative of sine u, so dy over du is cosine of u. So dy over dx is cosine of 4x. So I just went ahead and plugged in u is equal to 4x right away, times 4, which is the same as 4 cosine of 4x. Okay, and that will be all for this video.